Okay, so for this first question, we were supposed to weigh in a few compounds to make up a solution. And let's go for the sodium chloride first. So we have the sodium chloride, which has a molecular mass of 58.44 grams per mole. And it says we should make 200 milliliter of 342.2 millimolar solution, which can also be written as millimole per liter. And the easiest way to do that is with dimensional analysis. So we are looking for the amount of grams that we have to weigh in. So this is grams. Do we have grams anywhere? Yes, we've got grams here. So we write this as 58.44 gram per mole. Now the gram is okay, but we need to get rid of the moles. So we need to find something with moles in it. And we've got that here. And so we write it that the moles cancel each other out. We write it as 342.2 times 10 to the minus 3 mole. That's minus 10 to the minus 3. That's the millimole here. Mole per liter. So we see that the moles cancel out. And we now need to get rid of the liter. Do we have liters? Yes, we've got liters here. So times 200 times 10 to the minus 3. That's again the milliliter. So the liter cancel out. And the unit that we've got left is here, these grams. So we can write this as 58.44 grams times 342.2 times 10 to the minus 3 times 200 times 10 to the minus 3. And if you put that in your calculator, you will get exactly 4.0 grams. So we need to weigh in 4 grams. Now we also need 200 milliliter of a 2% weight per volume agar to solidify the plates. So again, we need to find out grams of agar that we have to weigh in. And we know that 2% actually means 2 grams per 100 milliliter. So that is this weight per volume. So we've got grams here. So we've got 2 grams per 100 milliliter. And we want 200 milliliter. So again, we write it that the milliliter cancel each other out. And which is like that. And we have equals 2 grams times 200 divided by 100 equals also 4 grams. So that is our agar. That's the sodium chloride, and that is the agar. And last but not least, we need 100 milligram per milliliter stock. So I write this here because I'm running out of screen estate. So we want 100 milligram per milliliter stock solution, and we want 10 milliliters of that. So again, we want to find out how many grams do we have to weigh in. So grams in this case. Now we have 100 milligrams per milliliter. I can also write this as 0.1 gram per milliliter. 100 milligrams is the same as 0.1 grams per milliliter. I've got my gram unit here, and I want to get rid of the milliliter, so I just simply multiply that by 10 milliliter. The milliliter cancel out, and I've got 0.1 grams times 10, and that gives me exactly 1 gram of the antibiotic. Antibiotic that I have to weigh in. Now, if you have tried to use this one here, because it has a gram in it, let's see what happens. So grams, and maybe you said 349.4 gram per mole. And you have the gram here, but you don't have anything to cancel out the mole. So this basically doesn't work. And therefore, you couldn't use this molecular mass in order to do any calculation here. So that's why some people probably run into a little bit of a problem with this approach. This approach here gives you the right answer, and again, you basically had to choose between using this and this, but hopefully you found out if you use this one here that it doesn't work and changed your strategy very quickly. So that was question 1. Thank you for watching.